Okay, look at the best way of adding vectors together. So, the best way of adding vectors together is to put them in a coordinate plane and find the x component and the y component of the vectors. So, for example, let's put the Hamsang of A, or the actually the equivalent of A here. So this is A now. I don't need this anymore. I don't need a crowded place. And let's put the B here. And the B seems that is like this. Okay, this is the B. I don't need this here. I have the A and B in place. Now I want to add them together. Of course, if I want to calculate and have the exact numbers, first I will find the AX. In this case is 3, of course, and the AY is 2. So let's write it here. The A actually is AX is actually 3, AY is actually 2. Now let's find the B. The B also, if I draw perpendicular to the x-axis, it's meeting it at 1. So the BX is 1 and the BY is actually 2, 3, 4, 5 is 5. Okay. So now finding the addition, let's say A plus B equals to a vector called C. Yeah, so I'm looking for C here, and C would be, of course, the CX would be 3 plus 1, which is actually 4, and the CY would be 2 plus 5, which is 7. So let's draw that one. 4, 2, 3, 4. So I draw perpendicular here, and 7. 1, 2, 3, 4, 5, 6, 7. Okay, this would be my C, which is the addition, which is A plus B. And of course, as you can see, it doesn't matter if I change the orders, I just need to make sure I put the numbers correctly. As you can see, you can actually draw your parallelogram method, and it will give you the same answer, or your triangle method, that also will give you exactly the same answer. But this is the best way because you can make as many as you can add as many as vectors as you like together, and you get the exact number. So for example, let's try some here actually. Okay, let's have a vector here. Okay, let's say for example have A. This is another A, which you can see giving me 2, 3, 4. 4 for X, 2 for Y. Let's draw a B. Let's draw the B here actually. Okay, this B is giving me the Y equals 4 and negative 4 actually. This is the B. Let's draw a C, which is here. And this is my C. Okay. Negative 5 for the Y and negative 2 for the X. So I have a I define a D, which is actually, I know a D, which is the addition of A plus B plus C. I can change the order, doesn't make a difference as long as I put my numbers correctly. For example, this is the dx and this is the dy. The x's must be added together, which is in this case 4 plus negative 2. Oh, actually, I can put, doesn't matter really, but let's put the c first. I can put that too, but negative 4 for the c, for the b, and for the c negative 2. It wouldn't make any difference if I would put them all in different orders. It would be the same as long as I add the x's together and make sure I put the negative and positives. Of course, the answer for this one is negative 2. Yeah, and the dy is the addition of all the y's. Of course, I have let's change this time. I can put the order, I can change the order too, doesn't matter. For the y's, I have 2, I have 4, and I have negative 5. Of course, the answer would be 1. Yeah, negative 1. Yeah, the answer would be 1. Okay, so I can easily draw my d now, which is negative 2 for the x and 1 for the y. Actually, this is the addition of all of these vectors in here. This is d. D ended up being smaller than all of them because there is negative involved, of course. So yeah, so you can this method is good because you can add as many as forces as you want, and this or as many as vectors as you want. So this is very, very good method.